Hello everyone. In today's video, I will be going over the Unit 2-1 study guide for Precalculus. Number 1 is going to take quite a bit of time because there are so many things you have to find for each equation, and on top of that we have to graph them. So make sure you have a sheet of paper or maybe several sheets of paper handy as we're going to use them on number 1, and then some of the other problems we'll have to have paper on hand because there's just not enough room on the page. So, for each problem on number 1, we need to put the equation into vertex form. Then we'll identify transformations. Then we'll identify the vertex, the axis of symmetry, the intercepts, and finally we will graph what we have. So, our first problem is f of x equals x squared minus 12x plus 7. And the first thing we need to do is put it into vertex form. This is done by completing the square. First thing we need to do when we complete the square, we need to write the equation, and I'm going to change that to a y. The first official step is to move the c term over here with the y. So in this problem, that's 7. So we'll subtract the 7 over here. And that leaves us with x squared minus 12x. Our next step is where we're going to actually complete the square. We do that by adding that b over 2 squared to both sides of our equation. So our b term is negative 12 here. It's attached to the x. And so right here, we're going to do negative 12 over 2 squared, which is negative 6 squared. So that's what we're going to put in here. And then I'm going to put it on both sides. Now I simplify. So on the right side, this simplifies to just x minus 6. The whole thing is squared. If you don't believe me, take a moment. 6 times 6 is negative 6 times negative 6. Still positive 36. That's what this is going to be. And then negative 6 plus negative 6 is negative 12. So it works. Over here, I have y minus 7 plus this is positive 36. Then I'm going to simplify here. Negative 7 plus 36 is a positive 29. And then x minus 6 squared. Last step is I need to move the 29 back over here, so I'm going to subtract the 29 over. So y equals x minus 6 squared minus 29. Now I'm going to give you a pro tip here. And I'm partially doing this for my own sanity. Full disclosure, this is the second time I'm filming this because first time I put plus 29 on the right side instead of a minus, and that messed up my entire problem. So, on the graph, these two should come out the same. Your original and your vertex form. These are the same equation. They represent the same graph. They're just in two different forms. So one way to make sure this is correct is graph these together. The lines should overlap completely. So here I have x minus 6 squared minus 29. So the blue and then the red. Can't see that very well. Just a moment. All right, I adjusted the brightness. Let's try that again. So like I said, if these are the same in the calculator, these should overlap colors. So when I graph it, notice that the blue shows up first, and then the red appears right over top of it. So that means that these represent the same graph, same equation, so I'm on the right track. I'm going to keep going. Just a quick warning, a lot of the information I'm about to find in these next few parts, you can technically get from the graphing calculator. If it says show work, you need to show the work by hand. If it doesn't say show work, then you are free to use your calculator to find those details. But sometimes by hand is still a bit quicker. Second thing we need to find is we need to identify transformations. So the parent graph for our function is just y equals x squared. I like to note that because it's very nice when you can compare what it's supposed to look like to the transformed version. And then our equation is y equals x minus 6 squared minus 29. If you identify the parent graph, then it just gives you an opportunity to just spot the differences, if you will. First thing to point out is we have x minus 6 here. That tells us that the graph moves right 6. And then minus 29 tells us that the graph moves down 29. So these are our two transformations. If you just want to make a list with commas, that's fine. This is how I've been writing them in Algebra 2, so it helps. Okay, we've identified transformations. Step 3, identify the vertex. The vertex comes from our equation in vertex form. Y equals x minus 6 squared minus 29. So we try to find the h and the k in the vertex. H is where this negative 6 is, but we ignore the sign, or in other words, we change the sign. So if that looks like a negative 6, we understand it's actually a positive 6. Negative 29 we take at face value. So my vertex is positive 6, negative 29. Fourth item is the axis of symmetry. Now, in our transformations, we don't have a reflection or anything, so I know for a fact that my parabola, my quadratic, is just going to be that nice U shape. So we're going to have a U shape, vertex, 6, negative 29. Reminder, the axis of symmetry is just the vertical line through that vertex. We write our vertical line as x equals, and then the x value of the vertex. So x equals 6. And that's it. 2 more items. We have to find the intercepts and graph. Since I have this space I'm going to waste over here, I'm going to just continue my work over here. So step 5, intercepts. So first we're going to look for our x-intercepts. Reminder, if we do this by hand, that means we're going to plug in 0 for y, solve for x. So our equation, just over here, y equals x minus 6 squared minus 29. So I'm going to have 0 equals x minus 6 squared minus 29. Solve for x, add the 29 over. Next, we have to get rid of the square. We do that by square rooting both sides. We have square root of 29 over here. And then the square root and square cancel, so we have x minus 6. And we can take off the parentheses now. Reminder, since there's an x involved in this, this is technically plus or minus 29. The square allows us to have 2 values of x to work here. Last thing we need to do is move the 6 over here with the 29. Sorry, with the plus or minus square root 29. And when I do that, I'm going to put the 6 in front. So that gives me my x. And then plus or minus means I have 2 possible solutions, so I need to find both of them. So I'm going to separate this into 2 categories, or 2 answers. 6 plus the square root of 29, and 6 minus the square root of 29. Obviously, this is not going to be a nice decimal. So as far as how to round, it's kind of your choice. I don't believe we give you any directions on that. If we do, pay attention to those. But I'm pretty sure we don't. So if it comes out like this, personally, I like tenths. That makes my life easier. So 6 plus the square root of 29 is 11.4, approximately. And then 6 minus the square root of 29 is approximately 0.6. So those are going to be my x-intercepts. I'm going to come back here, fill those out. 11.40 and 0.60. Lastly, I find the y-intercept. This time we put in 0 for x, much easier to find. So my equation, I have y equals 0 minus 6 squared minus 29. Y equals, that would be negative 6 squared minus 29. Negative 6 squared is a positive 36 minus 29. And give me 7. So my y-intercept is 0, 7. Okay, all of that work is so that we can make a graph of this equation. Now this graph does not have to be perfect by any means. And how much we graph just kind of depends on how good or bad our points are. So step 6, graph. So we need points. First point we'll graph is our vertex. Our vertex was 6, negative 29. And then we have our intercepts. That's x and y intercepts. Starting with our x-intercepts, we have 11.40 and 0.60. And then our y-intercept was 0, 7. So we're going to graph all 4 of those. And I guess I'll go by 5s on my graph. And I'll need to go up to 30. So if I got 30, 25, 20, 15, 10, 5. So this will be the middle of my graph. And then I'll have 6 notches down here for those negatives. And then 6 to the right. And 6 to the left. I'm not going to number all the way around because you get the idea. Now let's graph. Our vertex is 6, negative 29. So 6 is going to be right about here. And then negative 29 is going to be very close to that bottom tick mark there. So there's the bottom of our U shape. That's our vertex. Our intercepts are at 11.40. So about right here. And 0.60. And then lastly, our y-intercept is at 0, 7. So right about there. Lastly, I'm going to draw in my graph. I'm just going to freehand it here. Make sure it has that nice U shape. And I do have my 3-point minimum here, so I don't have to worry about finding anything else. And then just to demonstrate, our axis of symmetry would be through, did not mean to smear the blue. That's okay. Be through that vertex. The axis of symmetry basically cuts this in half, visually speaking. If you don't graph that on the test, it's not a big deal. All right, that was one problem. We're at 15 minutes. This is going to take a minute, to say the least. 2 more from number 1. The good news is the rest of the study guide is not that time-consuming. It's definitely the worst of it. Letter B. F of x equals negative 4x squared plus 16x minus 8. So part 1, we put it in vertex form. I'm going to go a little bit more quickly this time around since I've slowed down and taken my time on the first problem. Y equals negative 4x squared plus 16x minus 8. Add the 8 over. Y plus 8 equals negative 4x squared plus 16x. There is an extra step here we have to consider. Before we complete the square, we have to only have x squared. We cannot have a negative 4 there. So we're going to factor this out. So y plus 8 equals negative 4. Factor out negative 4 here. It's just x squared. And then when we divide 16 by negative 4, we're left with negative 4x. Now I'll complete the square on both sides. Something I'm going to do now before I forget. Since I have this negative 4 in front over here, to make this balanced, you have to put a negative 4 over here as well. So, negative 4 times whatever this turns out to be. I have to have it on both sides to make it balanced. If this is still something that confuses you, let me know. I'd be happy to work this out and show you why this is important. All right. B over 2 squared. That is negative 4 over 2 squared. Negative 4 over 2 is negative 2. So negative 2 squared, leave it like that. So this is negative 2 squared over here. Negative 4 times this, it condenses down to x minus 2, the entire thing squared. And then over here I'm going to simplify y plus 8. This becomes a positive 4 times negative 4 is a minus 16. 8 minus 16 is negative 8. Bring down the negative 4 times x minus 2 squared. Add the 8 back over. I'm going to pause for a moment, graph both those in my calculator to make sure I'm on the right track. I will show you that when I do it. All right, it is ready to be graphed. There's the blue. And the red right over top of it. So since they are completely on top of each other, that means that this is the correct form of this equation, and I can move on knowing I am on the right track. Step 2, transformations. Going to look at this from left to right. So the original parent graph is just x squared. So first thing I see is this negative 4. This is actually 2 transformations in one. The negative tells us a reflection. And I'm just explaining here. It's because of the negative. And then this is a stretch of 4. Vertical stretch of 4. Technically. Make sure you put vertical, I completely forgot. X minus 2, that means we're going to move the graph right 2. And then plus 8 means we're going to move the graph up 8. So there are 1, 2, 3, 4 transformations here. Third item, vertex. Looking at our equation, we have a negative 2 inside with the x, so that's going to be thought of as a positive 2. And then plus 8 stays up an 8. So 2, 8. Axis of symmetry, I'm just going to write AOS this time. So the equation x equals our x coordinate in the vertex, so 2. Fifth item is our intercepts. I'm going to go to the back side of this paper for that. So first we need to find the x-intercepts. That is not even close. Intercepts. So that's when we do 0 for y. And our equation was y equals a negative 4 times x minus 2 squared plus 8. X minus 2 squared plus 8. Yep. Okay, so 0 for y. 0 equals negative 4 times x minus 2 squared plus 8. First thing, subtract the 8 over here. Divide by negative 4 on both sides. This cancels. X minus 2, whole thing squared. This is positive 2. Square root both sides. This becomes plus or minus. X minus 2 equals plus or minus the square root of 2. Add the 2 over. We have 2 plus or minus the square root of 2 equals x. So now we have two answers for x. We have 2 plus the square root of 2 and 2 minus the square root of 2. Two plus the square root of 2, that's approximately 3.4. 2 minus the square root of 2, that is approximately 0.6. So my x-intercepts are 3.40 and 0.60. Now I am going to find the y-intercept. This is when we plug in 0 for x. So we have y equals negative 4 times 0 minus 2 squared plus 8. Negative 4, 0 minus 2 is negative 2 squared plus 8. Negative 4, negative 2 squared is a positive 4 plus 8. This gives us negative 16 plus 8. That gives us negative 8. So our y-intercept is 0, negative 8. Last but not least, we graph. So we have to gather our points. The vertex was 2, negative 8. Positive 8. 2, 8. Just 2, 8. So that's our vertex. Next, our intercepts. We had 3.40, 0.60, and our y-intercept is 0, negative 8. Lastly, we make the actual graph. This one I don't have to go nearly as high up to get all my points on the graph, so I will just go out to 10. And I'm going to go by 5s just because of space. Normally I would go out by 1, but I don't have a ton of space here. 2, 4, 6, 8, 10. Okay. Our points, we have 2, positive 8. So we'll write 2 down 8. Gosh, 2, positive 8. I'm losing my mind here. 2, positive 8. Write 2 up 8. 3.40. It's going to be about right here. 0.60. And then 0, negative 8. Again, I have my 3-point minimum, so we are good on points. I don't need to find any others. So, as you can see, this is my vertex. I plotted that first, and it is going downward. Remember, it should be going downward. We talked about in the transformations how it has a reflection. So that means this is going to be flipped over itself. Again, if you're not sure, you can always check this against your graphing calculator. I showed you how to verify that your vertex form is correct with the calculator. So you are welcome to use the graph calculator to help you graph it as well. One more. That one took me closer to 10 minutes, so we're making progress. Part C. F of x equals 4x squared minus 12x plus 3. First thing we need to do is put it into vertex form. Rewrite this as y equals 4x squared minus 12x plus 3. Move c over. Y minus 3 equals 4x squared minus 12x plus 3. That plus 3 is gone. Okay. Factor out of 4 because we just want x squared here. That will leave us with x squared. And then negative 12 divided by 4 is negative 3x. Now we'll do the completing the square. Remember, since I have a 4 on this side, I have to put 1 over here as well, times whatever my b over 2 squared is. 4 times x squared minus 3x plus, we're going to figure out what that is in a sec. So here, b is a negative 3. So we have negative 3 over 2 squared. I don't really have an inclination as to whether to leave this as a fraction or a decimal. I feel like we should leave it as a fraction for now. If you want to make it a decimal later, that'd be fine. But I'm going to leave it like that. Negative 3 over 2 squared. So that goes over here as well. Simplifying, 4 times this we can rewrite as x minus 3 over 2 squared. And then over here, y minus 3 plus 4 times negative 3 over 2 squared is positive 9 over 4. If you remember cross-canceling, these 4's do cancel. So we're left with negative 3 plus 9. Negative 3 plus 9 is a positive 6. Lastly, move the 6 back over. Minus 6. Again, I'm going to take a moment to make sure that this is correct before I proceed. Moment of truth. First the blue, and hopefully we'll see the red. There it is. Excellent. Looks good. Let's move on. Step 2, identify transformations. So reminder, the parent graph is just x squared, so any additional numbers indicate a change. So first we have a 4 out in front. That 4 is a vertical stretch of 4. X minus 3 over 2, that is a movement right 3 over 2. If you didn't already know this or you haven't put it in your calculator, 3 over 2 is just 1.5. It's a very nice decimal. Lastly, minus 6 means down 6. So we have 3 transformations. And since there's no reflection here, our shape will look like a normal U, just something to think about, which I just showed you the graph, so you should already be aware of that. Number 3, vertex. Looking at our equation, our vertex is positive 3 over 2, negative 6. If at this point you want to look at this more as a decimal, 1.5, negative 6, that would be fine too. You'll definitely want to think of it as the decimal when you're graphing, so that would probably be helpful. Fourth item is the axis of symmetry. I'll go ahead and write that down here. That will take one line. Axis of symmetry. That's just x equals whatever the x value is in the vertex. Again, you have some options here. You can put 3 over 2, or you can put 1.5. Both are correct. Now I'm going to come up here to find my intercepts. First, we do the x-intercepts. I like to get those out of the way personally. And again, steps is an option. So that's when you plug in 0 for y. So our equation down here, y equals 4 times x minus 3 over 2 squared minus 6. So we have 0 equals 4 times x minus 3 over 2 squared minus 6. Solving for x, add the 6 over. 6 equals 4 times x minus 3 over 2 squared. Divide off the 4. X minus 3 over 2 squared. I'm going to simplify this down to 2/3 because why not? That's not 3. 3 over 2. There we go. Next, we get rid of the square by square rooting. And then don't forget that plus or minus in front. So now we have plus or minus the square root of 3 over 2 equals x minus 3 over 2. Last thing we need to do is add 3 over 2 over to here. So here we have 3 over 2 plus or minus the square root of 3 over 2. Let me add a little line here. Since I am going to put this into my calculator, I'm going to change these to 1.5, so it'll make my life easier. So we have 1.5 plus or minus the square root of 1.5. And 1.5, sorry, not the plus or minus, just the plus here. And 1.5 minus the square root of 1.5. I'm going to enter those in. 1.5 plus the square root of 1.5. That's approximately 2.7. And then repeat. 1.5 minus the square root of 1.5 is approximately 0.3. So those are my two intercepts for x. I have 2.70 and 0.30. Y-intercept. This is when we plug in 0 for x. our equation, we have y equals 4 times 0 minus 3 over 2 squared minus 6. You're doing this by hand, keep this as a fraction. Y equals 4 times negative 3 over 2 squared minus 6. Y equals 4 times 9 over 4 minus 6. Cross cancel, we're left with 9 minus 6. So our y-intercept is at 0, 3. Last step is just graphing. Step 6, graph. My points. My vertex was 3 over 2, negative 6. And then my intercepts, I had 2.70, 0.30, and then my y-intercept was 0, 3. So I have 4 points to graph. And this graph is not going to have to be that big at all. So I will just do 1 notches, or notches of 1. We need to go out to 6, since that's our largest number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So not the best spacing I've ever done. And we graph. 3 over 2, that's 1.5. Negative 6. About right there. 2.70. It's about right here. 0.30. And then 0, 3. And then we draw in our line, our U. And that's our graph. Okay, number 1 is done. I'll try to make the rest of the video as painless as possible. Write the equation of the quadratic function in vertex form, find domain and range. So for this problem, you don't have a starting equation, so you can't really complete the square. There is a specific way to do this problem, but there are kind of loopholes around it if you know what you're looking for. So I will talk about both of those things. So for the equation, you need to start with the vertex, and you should already be aware that your equation looks like y equals a times x minus h squared plus k. We can go ahead and fill in h and k, that's the vertex. The vertex is negative 2, negative 1. And so this is h and k. A times x minus negative 2, so h is negative 2, squared, and k is negative 1. So y equals a times x plus 2 squared minus 1. Problem, we cannot leave a as a. We have to solve for it. So once we find a, our equation is complete. So if you remember, to find the a, this is when we have to fill in a point for x and y to solve for a by hand, and then we can fill in a once we have it. So our other point on the graph is the y-intercept at 0, negative 5. So I'm going to have negative 5 equals a times 0 plus 2 squared minus 1. Negative 5 equals, this is just 2. 2 squared is 4a minus 1. Add the 1 over. I have negative 4 equals 4a. Divide by 4, I get a equals negative 1. So I'm going to put that back up in here. So my final answer is y equals -1 times x plus 2 squared minus 1. Now, if you know how to look for this in your graph, a lot of you are able to get the h and k filled in no problem, just with the graph. The a depends on how perceptive you are. If you notice that the u is downward, which is not what it's supposed to look like, it's supposed to be up, you'll notice we have a reflection here, meaning there's a negative in front. And then if we do the test for slope, and we move right 1 and meet a point, it is still down 1 over 1, like it's supposed to be, meaning there's no stretch or compression here. So if you know to look for that, you could have easily gotten -1. But if you didn't know how to find it, this is the process. Domain and range. Domain is just -infinity to +infinity. No jumps, gaps, or holes in the graph, and it keeps going in both directions. Range starts at -infinity, and as we come up the graph, we stop here at -1 with a point. So -infinity up to -1 is our range. It does not go any further. Number 3, identify the end behavior of the graph of the polynomial function. So to find the end behavior, you have to find the highest exponent, and you're going to take that whole term, and you're going to look at parts of it. So our highest exponent is the x cubed. So we're going to look at the -2x cubed. That's what we're going to focus on. First, we look at the exponent. We notice it is odd. Second, we look at the leading coefficient, LC, and we see that it is negative. So odd plus negative. Remember, odd is going to be a disco. Be a disco curve. And then negative, this is going to be a disco left. One way I explained it is that as it moves from left to right, it gets negative. So if you think of the disco curve, you got two options. You have, I'm just going to doodle this up here, disco left and disco right. If it's negative, it's going to get a negative. It's going to go down from left to right. So it ends up being negative when it's all said and done. So disco left. It's kind of one way to explain it. It also reminds me a lot of negative slope because it's supposed to go down from left to right. And then B, f of x equals x squared plus 4. So this time we've just got, this only has a exponent of 0. So x squared is going to be the term we're going to highlight. X squared, the 2 is even. LC, our leading coefficient, is a positive 1. So even plus positive. Remember, even is either going to be both up or both down. So if it's positive, it's a good thing they're both up. So I call this up and up. Or both up. Lastly, C, negative 3x to the 4th plus 2x squared minus 4x to the 6th plus x minus 7. Now this one's meant to trick you just a little bit. Reminder, we typically put the correct one at the front because that's how you're supposed to write it. But we will sometimes hide a higher exponent later on in the problem to see if you're paying attention. So whenever I do these problems, I always go to the front, note that this one's a 4, and then I look at the others just to make sure there's not another one that's higher, and in this case there is. So we have negative 4x to the 6th. 6 is even, so they're going to be both up or both down. LC negative 4 is a negative. Even and negative, that's going to give us down and down, both down. So at both ends of the graph, it's going to be pointing downward. Number 4, evaluate using the remainder theorem to find f of 3, use synthetic division. Definitely going to need a separate sheet of paper for that. Number 4, f of x equals 3x cubed minus 4x minus 7, and we want to find f of 3. Reminder, the remainder theorem says that f of 3 equals the remainder you get from synthetic division. So if I do synthetic division, the remainder is supposed to be the same as if I just plugged in 3 into here. So we're going to do it both ways to show that they work and that they match. So we're dividing by 3 for our synthetic division. My polynomial is 3 for x cubed. I jump over to x. I need something for x squared, so we're going to put a 0 in as a placeholder. Minus 4x, and then minus 7. To start, we bring the 3 down. 3 times 3 is 9. Combine, 9 and 0 is 9. 3 times 9 is 27. 27 minus 4 is 23. 3 times 23 is 69. And then 69 minus 7 is 62. So this is the remainder. So what that means, if this is correct, f of 3 should equal 62. I'm going to put a question mark here because we haven't actually checked that yet, but that's what this should mean. So now let's actually plug 3 in to see if this is the case. So this is our check. I want to clarify that. F of 3 equals 3 times 3 cubed minus 4 times 3 minus 7. 3 times 3 cubed should be 27. Yeah, it's 27. Minus 4 times 3 is 12, minus 7. And I do know this is 81. Minus, that's going to be 19. And I feel like I'll mess that up, so I'm just going to do it in my calculator. Yeah, I definitely would have messed that up. 62. 81 minus 19 is 62. And in case you don't believe me, I will put the whole thing in there just this one time, in case I might have made a mistake. Minus 4 times 3 minus 7. And this is an option from the get-go as well. Yes. Came out. We're good. So your final answer, they want us to find f of 3, would be this, without the question mark preferably. F of 3 is 62. Yes. Number 5, we're doing that again. Number 5 is f of x equals x to the 4th minus 10x squared minus 2x plus 4. And then this time they want us to find f of negative 3. And that's what we're going to figure out. Synthetic division first, then plug it in to check it. So then synthetic division, we're divided by negative 3. 1x to the 4th, where you don't have an x cubed, so 0. Negative 10x squared minus 2x, positive 4. Bring down the 1. Negative 3 times 1 is negative 3. Combine, we have negative 3. Negative 3 and negative 3 multiplied give us positive 9. Minus 10 is negative 1. Negative 3 times negative 1, positive 3. Minus 2 is positive 1 times negative 3 is negative 3. 4 minus 3 is a positive 1. So this should be my remainder, meaning this tentatively is 1. Let's check. F of negative 3 equals negative 3 to the 4th minus 10 times negative 3 squared minus 2 times negative 3 plus 4. Negative 3 to the 4th is positive 81. And then this becomes negative 3 squared is 9 times 10 is negative 90 plus 6 plus 4. 81 minus 90 is negative 9 plus 6 plus 4. Negative 9 and positive 6 give me negative 3, plus 4 gives me a positive 1. This worked. This matches what I got for my remainder, so this is correct. We are done with that. Number 6 asks us to just use synthetic division. So we have negative 2x to the 5th minus x to the 4th plus 2x cubed plus 10x squared plus x plus 1 divided by x minus 2. How we write this is just a tad different because this is a different kind of question. This is asking us to divide, and so our answer is not a singular number, it's an expression. So that's kind of the big difference between this and what we just did. So kind of keep that in mind. So our factor is x minus 2. So when we're dividing, we're not going to divide by negative 2. We're dividing by the 0, which is actually a positive 2. So this is when you change it from negative to positive or positive to negative, depending on which one you're given. Now we're going to fill this in. Negative 2x to the 5th minus 1x to the 4th plus 2x cubed plus 10x squared plus 1x plus 1. We don't have anything skipped in between, so we are good on that. Synthetic division, bring down negative 2. 2 times negative 2, negative 4. Negative 4 and negative 1 give us negative 5 times 2 is negative 10. 2 minus 10, negative 8, times 2 is negative 16. 10 minus 16, negative 6, times 2 is negative 12. 1 minus 12 is negative 11, times 2 is negative 22. Negative 22 and positive 1 give us negative 21. That is the remainder. Now, I'm not going to do this by hand just because I don't want to write all that out. I'm going to pause and come back. Give me just a sec. So here's another pro tip to kind of check your work. Make sure you're on the right track. Good thing to know when you're taking a test that you are doing this correctly. What I just did off camera is what we just did with the remainder theorem. Just to make sure I'm on the right track, I checked. Remember, if you plug this number directly into that equation, so not with the x minus 2, but just all of this, your answer should be the same as the remainder. So I did that. You can't see all of it, but you can see most of it. And it does come out to be negative 21, just like the remainder. There is a very small chance that I still made an error through here, but it would be pretty hard to mess up somewhere in here and still end up with the correct remainder. So this makes me feel pretty good about my answer. This is not my answer, by the way. This is just a way to check my answer. Remember, when you're dividing, your final answer is going to be a polynomial. So if this is the remainder, negative 11 is the constant. So we go in order. So if this is the constant, negative 6 is attached to x, negative 8 is attached to x squared, negative 5 is attached to x cubed, and negative 2 is attached to x to the 4th. Something I want to mention if you never picked up on this when you learned synthetic division last year, the highest exponent in your answer is going to be one smaller than what was in your polynomial, or it could be. We could not have an x to the 4th at all. It just depends. But the highest it could be is x to the 4th. So just kind of an FYI. So that's where I'm getting this from. I start at the remainder and I go backwards. So I'm going to write my final answer. Negative 2 x to the 4th minus 5x cubed minus 8x squared minus 6x minus 11. You have to include that remainder in your answer. Remember to write your remainder plus, this is just me explaining. You got to put your remainder under here. Your remainder is negative 21 over the factor. Gosh, why am I writing the word factor? Not the word factor. Your factor, which is x minus 2. With or without parentheses, that's up to you. So this is the final answer. And that is how you have to write it. All right, that is the front side of the study guide. Now let's look at the back. Okay. Number 7. If the roots are 5 and -4, find the polynomial equation of least degree. And I'm going to add a little bit in standard form, because that's how I taught it to you guys. Standard form. So this is that roots to equation type of problem I showed you, where we're used to taking an equation, factoring it down, and getting the roots. We're working backwards. We start with the roots and we come to an equation. Not a super difficult concept, it's just a lot of algebra. So our roots are 5 and -4. So if you remember, the first thing you do is you set these both equal to x. So now we have x equals 5 and x equals -4. And then we want to have these equal 0 instead. So we're going to subtract the 5 over and add the 4 over. So now we have x minus 5 equals 0 and x plus 4 equals 0 to create factors. Then we can multiply these together to make an equation. So to start our equation, we have f of x equals x minus 5 times x plus 4. And then we multiply those together. X times x is x squared. X times 4 is 4x. -5 times x is -5x. -5 times 4 is -20. And then we simplify where we can. We can simplify these middle terms. X squared, 4x minus 5x is -1, or just -x, minus 20. And that is our answer. So I want to elaborate on something here because this isn't terminology I used. Of least degree. This means this is the smallest possible equation we can make with these roots. So we could have other possible ones, but this is like least degree. This is the best way I could explain it. Just start with the only information you need. Your roots, create your equation, you're done. Number 8, similar problem. I'm using a lot of paper here. Number 8. If the roots are 1, 2, and -3, find the polynomial equation of least degree. Same thing. So my roots are 1, 2, and -3. So I write those as x equals 1, x equals 2, x equals -3. Then I want them equal to 0. So x minus 1 equals 0. X minus 2 equals 0, x plus 3 equals 0. Now we have factors, so we can put them all together to make an equation. X minus 1 times x minus 2 times x plus 3. Now I have to multiply those together. When I've got 3 or more, you have to do this in multiple steps, and I like to do the back first so that when I distribute, it looks more natural since it's coming from the front. You can multiply these in any order you want, though. Multiplying, I have x times x is x squared. X times 3 is 3x. -2x here. -2 times 3 is -6. Going to take one more step to simplify before I multiply again. X squared, 3x and -2x give me a plus x, and then minus 6. Now I multiply this x minus 1 into my trinomial. Pro tip, multiply the x through first. That's going to put your exponents in order for the most part, and then multiply the -1 through. So x times x squared is x cubed. X times x is x squared. X times negative 6 is negative 6x. And now the negative 1, which essentially is just going to change all of the signs. So I'll have minus x squared minus x plus 6. My favorite part, I actually do enjoy doing this, simplifying. And as I do this, I'm going to take a pencil and mark off things as I go. My highest exponent is up front where it should be, x cubed. Done with that. Look for x squared minus x squared. Well, those cancel, so they're gone. Nothing to write there. Negative 6x minus x, that's negative 7x. And then plus 6, positive 6. There's my equation. And we are done with number 8. Also, I have not been putting any answers on this paper, so I apologize for that. I will be starting now. There you go. Number 9, just identifying stuff. Nice little break. I think I meant to say identify the zeros, max turning points, multiplicity. Oh, and sketch the graph. Yeah, this is going to take a little bit longer than I'd like it to. But I know a lot of us need practice with this. So I'm going to do this on a separate piece of paper because I don't know how much room I'm going to need. So we're on number 9, A. G of x equals negative 2x cubed minus 4x squared. And I'm going to make the list of all the things I need to find first. That helps me personally. I'm sure it helps some of you guys too. So if I don't write it all out, there's a good chance I'll miss something. And I'm glad it says max turning points, because remember, the numbers that we'll find for zeros and turning points, that's a maximum. That's not a guarantee. Multiplicity. And then sketch the graph. When it says sketch, that means to the best of your ability. It doesn't have to be perfect by any means. So our graph, or our equation, g of x equals negative 2x cubed minus 4x squared. So first I need to find the zeros. So to find the zeros, that means factor. When you're factoring, you should have kind of a list of things you're looking for. So when I look at this, when we hear factor, the automatic thing we think of is slide and divide. Well, unfortunately, that's not going to work here. So my immediate reaction here is, let's look for a GCF. And we do have a GCF. First, I'm going to see if I can pull out any x's. I can pull out x squared, that's the maximum. If I pull out x cubed, I'm not going to be able to take that out of there. Now we'll see if I can pull out a number. 2 and 4, they both share 2. On top of that, it won't make a huge difference if you don't do this now, but since they both are negative, I'm going to pull a negative out as well. So dividing negative 2x cubed by itself, I'll be left with 1. And then this will turn into a plus. And then my x's are going to be, oh, shoot. Let's take out x squared. I don't know why I said x cubed. Okay, so we're actually going to have just an x there. Sorry about that. Yeah, so negative 2 is gone, and then x cubed divided by x squared is left with just x. And then negative 4 divided by negative 2 is a positive 2, x squared. No more x squared, so it's x plus 2 there. And that's all the factoring I need to do. So we need to find the zeros. So this is where we take these two factors and we set them both equal to 0. So we have negative 2x squared equals 0. And x plus 2 equals 0. Solving for x. The short answer, this is going to be 0, but I'll demonstrate. Divide by negative 2. 0 divided by negative 2 is negative 2. Equals x squared. Square root of 0 is 0. It's 0. And then this is negative 2. So my zeros are x equals 0 and x equals negative 2. You can leave them like this. You can write them as points. I like to do both. So this is 0, 0, and this is negative 2, 0. So we found the zeros. Now the turning points. This part is actually very easy. So our degree is 3. Remember, degree is the highest exponent. So if we go back to our equation, highest exponent is the 3. So the number of turns, that's our degree minus 1. So 3 minus 1, which equals 2. And remember, this is a maximum. It's not a guaranteed number. And then our multiplicity. So our multiplicity is typically something I do in conjunction with the zeros. So I'm doing this out of order even for me. Multiplicity. So I'm going to write those zeros down here again because you want to pair those together, the multiplicity with the zeros. So I had x equals 0 and x equals negative 2. So let me come back up here and look. X equals 0. This had a squared exponent with it, meaning its multiplicity was 2. And since it was 2, that means it has even multiplicity, which means the point bounces. That's going to be important information when we're graphing. And then negative 2, this came from this factor here that had an exponent of just 1. So, had a multiplicity of 1, which is odd, which means the point goes through. Okay, next all we have to do is graph. And just real quick, I know they didn't ask for it, but another thing you like to look for is the y-intercept. The good news is this is really easy to find. When I do y-intercept, I go back up to the original equation, not the factored one. If I plug in 0 for x, these both go to 0. So my y-intercept is 0, 0. Which is also an x-intercept. So I'd be graphing it anyway. So step 4 of the graph, this does not need to be perfect by any means. We're basically graphing the zeros, the y-intercept, and then looking to see what happens with the graph. And I don't have to go out very far at all. My zeros were 0 and negative 2. I'll just graph extra because why not? So we have 0 for my first 0 and then negative 2, 0. One other thing I wish they would have asked for in the directions, because some of you may not think of this, you also need to know in behavior. Because in behavior dictates how your graph looks. In behavior, you need that degree term. So highest degree term is here. So I'm going to bring this down, negative 2x cubed. So 3 is odd. And our leading coefficient is negative. Odd plus negative. Odd is a disco. So it's be one of these two. And negative means it ends up negative. So it ends up pointing down at the end. So it's going to be disco left. Starts positive and it gets negative. So I'm going to have some graph over here on the left, and then this graph is going to come and hit the 0. This is going to be the left end of my graph. So according to this shape, the left end of my graph is pointing up. So it points up, the left end. Then it comes down and hits the x-axis at negative 2. And then at negative 2, has an odd multiplicity. It just goes through the point. Now, I know at some point I'm going to have to come back up and hit this. So I don't know when that is. I'm going to go ahead and turn this thing around and head back up and hit the x-axis here. Now, at 0, even multiplicity, this is going to bounce, which should make sense because it's not going to come back up again. So if it goes up, this would not match my end behavior. It would have to bounce so that it goes back down and creates that disco left shape that I'm looking for. all of this stuff comes together and it basically serves the bigger purpose in the bigger picture. All of these little details do work together in a meaningful way. All right, that was A. B. G of x equals 3x to the fourth minus 3x squared minus 60. So I'm also, sorry, I'm just kind of going rogue here. First, we're going to find the zeros. To find the zeros, we have to factor. So to factor this, I'll tell you what I'm thinking, because I had to think about this one for a sec. GCF, that should always be first thing. There's a GCF here. You have to pull out this GCF. We can pull out a 3, so let's do that. X to the fourth minus x squared minus 20. Next, we can't pull out any x's. This is a trinomial, which is not how you're used to seeing it. So normally, our trinomial, ideally, would look like x squared minus x minus 20. This is a very similar concept, and then usually this would be written as 2 factors of x, and then we would fill in our numbers with slide and divide. This is a very similar concept. Instead of having 2 x's here, we're going to have 2x squareds. Because if I multiply these back together, I'm going to get x to the fourth. And then when I add my middle terms, the middle term will have an x squared in it. I will multiply this back out if you don't believe me after I'm done factoring. So, I'm going to make my ACB table. ACA is 1, so it's negative 20. And then middle number is negative 1. I need two factors of 20. That will give me negative 1. Since 20 is negative, I know I'm going to have 1 negative, 1 positive. I'm going to go ahead and tell you, my factors are 5 and 4. And then specifically, if I subtract these, I can get 1. If I'm subtracting the 5, I'll get negative 1. 4 minus 5 is negative 1. So my factors are x squared minus 5 and x squared plus 4. I'm going to take a moment to multiply this out for those of you who do not see this. I'm going to quickly multiply this back out. X squared times x squared is x to the fourth. X squared times 4 is 4x squared. Negative 5 times x squared is negative 5x squared. Negative 5 times 4 is negative 20. X to the fourth, 4x squared minus 5x squared is a minus x squared. 4 minus 5 is negative 1 minus 20. That is what I started with. This does work. All right. And then don't forget to bring down the 3. That is important. Kind of. Something I want to mention, you should also be looking for possible difference of squares. We don't have that here. 5 is not a perfect square. And then this is kind of a trick one. It looks like it would be, but since this is a plus 4 and not a minus 4, it does not work. So these are only zeros here. So for our zeros, we could set 3 equal to 0, but since 3 clearly does not equal 0, 3 is not considered a 0. So our zeros are x squared minus 5 equals 0, and x squared plus 4 equals 0. All right, proceeding, we have to solve both of these for x. I'm going to do the left one first. Add the 5 over, I have x squared equals 5. And then to get rid of the squared, I need to square root both sides. Don't forget the plus or minus. So x equals plus or minus square root of 5. So x equals square root of 5, and x equals negative square root of 5. Solving over here. Subtract the 4, x squared equals negative 4. Square root both sides. X equals plus or minus the square root of negative 4. Want to refresh your memory in case you forgot. You cannot take the square root of a negative, so this does not work. So these zeros are gone. So I want to clarify something here. When we're talking about multiplicity, I know we're not talking about it at this moment, but I'm going to talk about it in just a moment. I'm going to give those answers in a moment. I want to clarify something. I understand up here we have a squared. The factor has an exponent of 1. Inside of this singular factor are 2 x values. So these are 2 different zeros, each with a multiplicity of 1. Had we gotten 2 out of here as well, the same thing would have happened. I would have had my 4 zeros, which is the maximum number I'm allowed to have, since this equation has a degree of 4. But 2 of them do not exist because of this, so we only have 2 zeros, and they both have multiplicity of 1. Just an FYI. Okay, next thing they want us to find is turning points, the maximum. So remember, that's your degree minus 1, so our degree is 4. So our turning points is 4 minus 1, so 3, and that's the maximum. Now in our last problem, we actually did have that number of turns, but we will not have that in this problem. Next, we're going to do multiplicity. I've already kind of talked about it with you. So we had 2 zeros, that's it. This wasn't actually a 0. 2 zeros here, these 2 don't exist because they give us a no solution. So 2 zeros, x equals square root of 5, and x equals negative square root of 5. They both have multiplicity of 1. Again, understand up here, that has x squared. We're talking about on the outside, not the inside. When I solve this, this is 2 different x values. It is not the same x value twice. That's what multiplicity is, the same x value twice. This is 2 different x values one time. Multiplicity 1, which means it's odd for both of them. Odd comes from the 1. And then that means that the point goes through. Next, we need to find, so I'm going to find the 2 extra details that are not asked for in the directions, the y-intercept. Call that 4a. Before I graph it, I'll call that 4b. Y-intercept. Again, for the y-intercept, I like to cheat. I like to go back to the original problem because that's way easier. If you plug a 0 into here for x, you get 0, 0, and negative 60. So y-intercept is 0, negative 60. And then end behavior, this is super important. This basically, literally, maps out what your graph looks like, and you need to use it as a guide. End behavior goes off of your highest degree, which is x to the 4th. So we're going to take that number in front of it with it. End behavior, this 4 means it's even. And my LC, leading coefficient, is positive. Even and positive means they are both up. Even and positive, they are both up. I call this up and up. Now we'll graph, so I'll call this 4b. Even if they don't ask for these details, it is very helpful to know, especially end behavior. It's kind of hard to graph it without that information. Then I want to say something, because this feels like a lot for me, so I'm sure it feels like a lot for you. those of you kind of panicking about all of this, reminder, you have your graphing calculator. So if you just get absolutely lost, you can kind of lean on it a bit. But obviously a lot of this still needs to be done by hand, unfortunately. So you can use your graphing calculator as a guide, but it can't do the work for you either. So my points. My zeros are at the square root plus or minus square root of 5. Let me see what square root of 5 is. Square root of 5 is roughly 2.2. So my zeros are at negative square root 5 and positive square root 5. So that's like negative 2.2 and positive 2.2. And then the y-intercept, going to, in a very crappy way, draw that in. So we'll have our notches here for 1, 2, and 3. So my zeros are at negative 2.2 and positive 2.2. And then my y-intercept is going to be somewhere down here. I'll get to that in a moment. And behavior is up and up. So the first time it hits the x-axis is going to be the left end. This end has pointing up. So it's going to be pointing up, and it's going to come down, it's going to hit the x-axis, and then bouncer through. It has multiplicity 1 for both of these. So on both of these, it's going to go through the point. So it goes through. And then it's going to turn around at some point. I don't know where this point is. If I cared enough, I'd look at my graphing calculator. It's going to turn around at some point so that it comes back up and hits this one. And then it's also going to come by and hit that y-axis at negative 60. Again, this does not have to be accurate by any means. And then it's going to come up and hit the other 0. And then it's going to keep going up and to the right. So we still have up and up. We hit our zeros. It goes through both points. And we have one singular turn in this graph. Okay, that was that. Now, we're going to go back to some more familiar territory, review from the last test. And if this is on here, that means you need to know it. From the ordered pairs, find f inverse of negative 3. This is a very commonly missed question on the test. This means f inverse. This does not mean f to the negative 1 power. We find the inverse of f by just taking all of these points and flipping the x and y values. So I'm going to do that first. F inverse of negative 3 equals negative 5, 10, negative 4, 8, negative 3, 6, negative 2, 4, negative 2, 2. Sorry, that's supposed to be f inverse of x. I did the whole function, not just negative 3. That's an x. Now, if they ask f inverse of negative 3, so they're asking, okay, well, look for, if now in this case x is negative 3, what is y? That's the question. So we're looking for a singular number as our answer, not a point. So if we go to negative 3, it gives you 6. That's the answer. If you write a point, you will lose credit. Number 11, determine the inverse function algebraically and verify. So this one's going to take a minute. This is something that a lot of you struggled with on the last test. So to find the inverse, our equation is f of x equals 6 minus x over 2. Remember the inverse, I am going to call g of x. That's going to help me when I'm verifying. So when I get that, I'm going to fill that in up here. To find the inverse, you replace this f of x with y. You flip these spots. So now we have x equals 6 minus y over 2. And then you solve for y. There's a few ways to go about this. What I recommend, any multiplication or division, wait until the end. You're more likely to mess it up if you do it from the get-go. So I'm going to move this 6 over here with the x, because again, I'm solving for y. So subtract 6 on both sides. x minus 6 equals, bring down that negative y over 2. And then to get rid of this, I just multiply by 2 on both sides because this is like dividing by 2. So to get rid of it, I multiply by 2 times 2, and actually negative 2, I almost forgot. I want to get rid of that negative as well. Now, here's the important thing. When you multiply, you're multiplying an entire side. So those of you who put negative 2 in front of this x, no. It's the whole thing times negative 2. So this cancels here and that negative. We're left with y equals. How you go from here is up to you. I do believe it's better to leave this out, but I could be wrong. So you can write this as negative 2 times x minus 6, or you can distribute in and get negative 2x plus 12. If I remember correctly, it's actually easier if you leave it undistributed, so I'm going to do that. I'll show you it does help. So my inverse is negative 2 times x minus 6. Now verifying, this was a train wreck on the test. You got to be a lot more careful with this. So to verify, you find two things, f of g of x, and you need to find that it equals x, and g of f of x, same thing. X is what it needs to come out to be. So for A, I'm plugging g into f, so all of this is going into this x. So f of g of x equals 6 minus g goes in for the x. So I'm going to introduce parentheses here. Negative 2 times x minus 6 over 2. Now here, when you simplify, you have to do this very carefully. A lot of you guys like to go rogue and just mark out things. You got a 6 and a negative 6, so that's gone. And we got a 2 and a 2, and that's gone. No. Do it a bit more carefully. So you have to simplify according to order of operations. So parentheses, if I'm looking inside the parentheses, I can't combine the x and the negative 6. They're not like terms. This distribution would be multiplication technically, so that does not fall under parentheses. No exponents. Next is d and m, divide and multiply. I can do that in any order I want. So this would be an appropriate time to mark out the 2 on the top and the bottom because they do cancel. Make multiple steps out of this. 6 minus, be careful with your signs here, that negative is still there. Negative x minus 6. Now I have to take care of this negative 1, so I'm going to distribute it in there. 6 minus, still in parentheses, negative x plus 6. Now I have another negative 1 I have to distribute. 6 plus x minus 6. Now is the time when you can mark out that 6 and negative 6 and end up with just x. There are a few other directions you could have gone with that, but that's pretty much how you do it. You have to be very careful here. Don't do this all in one step. That's how you make mistakes. That's how you divide incorrectly. That's how you forget about signs. It's very easy to do. So just take your time is what I'm saying with these. B, g of f of x, the other direction. This time, we are plugging all of f into this x in the g function. Negative 2 times, and then I'm going to use another set of parentheses here, 6 minus x over 2 minus 6. Simplifying, I'm going to do what's inside the big parentheses first. I'm going to focus here. I can't combine these, so I'm going to actually drop this inside set of parentheses. 6 minus x over 2 minus 6. this is where I would look to combining like terms. So the 6 and negative 6 I can combine, they cancel each other out. Now I have negative 2 times negative x over 2. And then the negative 2 and the negative and the 2 on bottom cross cancel. This is like division. Since we got one on top and one on bottom, cross canceling. That leaves us with x, which is what we're looking for. Remember, when you're verifying an inverse, the work is your quote-unquote answer. So your work has to be correct. It's not just about getting to x. It's does your work actually follow through? So that was 11. Number 12, graph and describe the transformation from the parent function. 3 times x minus 2 cubed plus 4. I'm going to do that at the bottom of this paper for 12. Now, if you remember these, there's not a ton for you to do here. You need 3 points. One of those points obviously has to be the vertex. And then you can use your graphing calculator to find those 3 points if you choose, and then just graph a general shape. So we had a quiz over this. Now, because of what we're doing in this unit, you could find a lot more stuff about this equation by hand, but for this kind of problem, I would stick with just the very basics. Don't get too overcomplicated. So we have I kind of prematurely make my graph. We need 3 points. We have the vertex. So first and foremost, the vertex is positive 2, positive 4. And then you want to also keep in mind the shape. This is a cubic function, so the shape is going to be disco right, which now you know how to find this, just an FYI, with the in behavior stuff. And then for the other points, I'm just going to go to my graphing calculator to make this easy. And give me just a moment, I need to fix my zoom. If your zoom is ever off, it needs to be in zoom standard, the 6th option. So it's going to look like that. And then if you didn't remember, didn't know, you can use the table to find other points. So you want to go lower than this. I'm going to have to change my settings on here. Okay, so 2, 4 is my vertex. 1, 1 is also a point. And yeah, I guess I'll do 3, 7. 3 points, remember. So those are the 3 points I'm going to graph. So I'm going to go out to 7, it looks like. And graph my points, 2, 4. 1, 1. And 3, 7. And then remember the shape has to be there. So the vertex was at 2, 4. And so this is kind of the center of the shape, that disco right shape. So that's right here where we're at. So this point, it's going to kind of curve to the right and go up. And this one's going to curve down to the left and just keep going down. And then I think the y-intercept is too low to see. So this is pretty close enough. 3 points, you got your graph. The other thing I need to do from the directions, describe the transformation from the parent function. So the parent function is y equals x cubed. So I'm going to list the changes I see from parent to what we would call child graph, the graph we have. First we have a 3. That is a vertical stretch of 3. Then we have the x minus 2. That means we're going to move right 2. And then we have a plus 4. So that means we're going to move up 4. 3 transformations, just those 3. Okay, 3 more problems. Number 13. Find the x and y intercepts of the graph of the equation. This shouldn't take too long. I'm going to start recycling some of this paper. Find the x and y intercepts of the graph of the equation. Y equals square root negative 8x minus 7. So for the x-intercepts, again, that's where we plug in 0 for y. And this one should only have 1 x-intercept, actually, if it does have 1. 0 for y. So 0 equals square root of negative 8x minus 7. This time we have a square root, and we want to get rid of it. So we square both sides to get rid of it. 0 squared is 0. This gives us negative 8x minus 7. Add 7 over. 7 equals negative 8x. Divide by negative 8. X equals negative 7/8. So our x-intercept is negative 7/8, 0. Now we do the y-intercept, which again is always the easiest to find, so I save it for last. This is 0 for x. So this time we have y equals the square root of negative 8 times 0 minus 7. Square root. Negative 8 times 0 is 0. Minus 7. Square root of negative 7. That's a no-no. We've already discussed this. It does not have one. And just to kind of show you and verify when you graph this, it looks like this. So you can clearly see it does not touch the y-axis. And it looks like it has a reflection. Oh yeah, because it's inside. There it is. So that does not work. Reminder, you can always plug that into your calculator as well to make sure your answer makes sense. So it does make sense that we don't have a y-intercept, but we do have an x-intercept. 2 more problems. Number 14. 14 and 15 are actually going to be pretty short. 14, does the table describe a function? What this is asking is, are all the x values different? No. The x values have to be different if you want a function. Y values can repeat if it's a function, but x values cannot repeat. And then if you want to know if the inverse is a function, then these can't repeat either. But for this one, can't have repeated x values. 15, determine the interval where the function is increasing. I know a lot of us enjoyed this on the first test. We're looking for intervals of increasing and decreasing. Remember, this feels like domain and range, but it's not quite the same. This has a lot more in common with domain. First off, we're looking at the x values only when we're doing this. X values. We do not write any y values here. Second, we always use parentheses. No brackets here. If you use brackets, we're not going to count off, but just remember, always use parentheses. We have 3 intervals here. Let's see what's happening. This one is decreasing. This one is increasing. This one's decreasing. So the middle one is the one we need to write down. Says which one is increasing. We want to note the ends of the interval. The left end starts right here. It starts at -2, so that's the start of the interval. That's when it starts increasing. And then it stops at +3. So it is increasing from -2 to +3. After that, it jumps back up and starts decreasing again. So this is the answer. All right, that concludes this very long video. If you're tired, trust me, I am too. This is a lot of material. I hope this video is helpful. I tried to explain everything as much as I could, but also tried not to take too much of your time, more than I had to go through all of these problems. Please take your time, go through this video, rewind, re-listen to it as much as you need to. Really pull out the parts that you're really struggling with. That way we can discuss those points in class before we take our actual test. I hope you have a wonderful day, and I will talk to you guys later. Bye.